Hey guys, just wanted to get another video out for you on expressing and interpreting remainders. So lesson 6.8, this will be your review video for lesson 6.8. If you have extra questions while you're working on math journals or math boxes, this is where I sent you. That or if you finished your math journals and math boxes, I asked you to come over to watch the video and then to answer the extra questions at the end. So let's show you real quick on what to do with expressing remainders. So we are going to start off with a simple question, just kind of remind you about what a remainder is. The word remainder, some of you are like, well, that sounds similar to the word remaining. Well, if someone is remaining, you're playing dodgeball and you are the only one remaining. You are the only one left. Okay, so a remainder, that's where we're getting that name from, remaining. It's what is remaining after all of your division has been completed. We're going to do a pretty simple question. We're going to say that there are 5 students. Okay, so I'll put that up here. 5 students, and they are equally sharing 6 eyeballs. Why? Because, well, Mr. Ellis has eyeballs laying around. Who knows why? But 5 students are sharing 6 eyeballs. Okay. Chromebook's not working great today, but that's all right. So 5 students are sharing the 6 eyeballs. The easiest way to show this is to show the 5 students. Okay. All right. So there are our 5 students. We're going to take one of each. So take an eyeball, place it on a student. So I just did that on my paper copy. Okay. That's not what I wanted. That looks like a smiley face. We'll just put a mark. So there's for student 1. Here's for student 2. Student 3. Student, maybe. Student 4. Student 5. And we still have 1 left over. What do I do with that? That is the 1 remaining. That is where we came up with our word remainder. It is what is remaining, because I cannot split this one. I cannot cut this eyeball into 5 little pieces. I already know some of you are saying, but you can. I already know that you're saying that in your head. Yes, I could do that, but it would be a fraction of an eyeball. If I cut this into little pieces, it would be a fraction. How many pieces would I need to cut it into? 5, because there are 5 students. So a remainder is actually a fraction. So that we'll get into that a little more, but a remainder is actually a fraction. So we have 1 remaining. So if I had the question 6 eyeballs divided by 5 students, well, what is 6 divided by 5? Well, it goes in 1 time without going over, correct? 5, well, if I went another one, that would be 10. So it only goes in 1 time without going over. I'm going to subtract that, and there is my remainder of 1, because 5 cannot go into 1 again. So 1 remainder 1. So the first one tells us how many are in each group. Well, each person is technically a group. How many did each person get? Each person had 1. Well, the remainder is how many do we have left over. We don't just leave a remainder and just leave it as 1. The answer is 1. It's not technically 1. We have a remainder left for a reason. Okay. Well, it's 1 out of what? 5 here. So there's where you get your fraction from. For our process right now, we are just saying 1 remainder 1. That will be our final answer. But for those of you who are asking about, well, you can cut it. You could cut this last one into 5 pieces. You could, but it would be a fraction. It's not a remainder, then it would be a fraction. So you could say that each student would get 1 and 1/5. Because I would cut this into 5 little pieces, and each student would get 1/5 of it. So you can say that a fraction, they would receive a fraction, but that's a little bit different. We'll get into that a little more. What I really want you to realize is just that a remainder is going to be this extra amount right here. We represent that with R1, remainder 1. So we have our whole number out front, 1, everybody gets 1, and then there's a remainder of 1 left over. If you have any questions, make sure you ask. I did say that I would have some extra problems on here for those of you who are interested or needing to do a little bit of extra. So here we go. We'll start off with a simple one. We'll go with 12 and 17. It's a double digit, so that'll make it a little more tricky, but it's really pretty simple once you start thinking about it. That's the first double digit that we'll do, but it's pretty simple if you think about it. What you're supposed to do, how many times is 12 going to 17 without going over? All right, now to the next one. Let's go with 3 and 101. That'll be a little more tricky, but solve those, put your name on the paper, bring it to me to check when you're done. If you have any other questions, feel free to ask me, ask a fellow classmate that looks like they're doing pretty well, but that's all I needed.